Welcome to the fourth topic of Module 5, Fiber Examinations. We will begin by defining the term fiber and then discussing the two main types of fibers. We will also discuss the information that can be gained by a fiber examination. We will discuss the differences between woven and knitted fabrics, and then the optical and physical properties that are used by a forensic scientist during a fiber examination. Finally, we will discuss the correct manner for the collection and packaging of fiber evidence. Fibers can be divided into several different categories, whether they are plant fibers, animal fibers, mineral fibers, or manufactured fibers. So what exactly is a fiber? A fiber is a unit of matter. It can either be natural or manufactured, and it forms the basic component for all of our fabrics and other textile products. It can either be a natural fiber or a manufactured fiber, and both of these can be subdivided. Natural fibers can either be plant-based, animal-based, or mineral-based, and manufactured fibers, which are actually polymer bases, can either be a natural-based polymer or a man-made chemical-based polymer. If we begin by talking about plant fibers are going to have a lot of different uses. They are commonly used for some clothing, a lot of different textile products. They're used in paper products and a lot of different cordage. So it's going to be very common to see plant fibers as part of an investigation. These are your more common plant fibers. They can also be subdivided according to their properties, which more or less is the section of the plant that the fibers are actually obtained from. So you can see there's seed fibers, leaf fibers, bast fibers, fruit fibers, and also stalk fibers. But all of these are considered plant fibers. The analyst may also have an occasion to examine animal fibers. So these are actually hairs from animals that have been processed to be used in the various products. So things such as various clothing or textiles, and a lot of the different brushes will have animal fibers. These are some of the more common animal fibers that are used for the various products. So you can see these can also be examined by an analyst as a hair. So the one thing that has to be done initially, if we're dealing with animal fibers, is the analyst needs to look very closely to try to decide, is this piece of evidence being used as a fiber, or is it actually a hair? And a lot of times the indication may be given because of how the fiber has been processed or the color of the actual material. There's also occasions where they might encounter mineral fibers. These are not as common anymore because usually this involved asbestos. But asbestos can still be seen in some samples. And then finally, manufactured fibers. So there's a wide variety of different fibers available to the forensic scientist. This shows you a chart that entails a lot of the various fibers again. You can see that your manufactured fibers are going to be divided between natural fibers and also the man-made fibers, whether or not they're cellulose-based, protein-based, or more chemical-based. Whether it's a natural fiber or a manufactured fiber, it's going to be used to establish associations. Things such as contact between that fiber and an object, contact between a fiber and a person, or contact between fibers and a particular scene. Depending on the amount of the sample, fibers are usually analyzed for their various microscopic characteristics. The first thing that an analyst might do, if it is two larger sections of fabric, they might attempt to determine a physical match of the pieces, more or less trying to determine if the pieces were one at an earlier time. So if we think about this, we have to think back to how fibers are actually formed and how fabrics are actually made. Yarns are the continuous strands of a textile fiber. The fabric is any woven, knitted, plaited, braided, felted, or non-woven material made up of fibers or yarns. You can see from this slide that the yarn is the basic unit of a textile construction. However, it can have several different forms in the construction of that yarn. It can be a single filament, or it can be several filaments that are laid together that don't have a twist. In many instances, the yarns are going to have a twist, and this can be determined whether or not it is an S twist or a Z twist. Once the yarns have been produced, they are either woven, knitted, felted, or bonded by different methods to actually make the fibers and fabric. Color can be imparted into the yarns and the fabrics either by the use of dyes or by pigments. Dyes will absorb and reflect the wavelengths of light, where pigments are going to actually be granules that will adhere to the surface of the fiber itself. Woven fabrics are composed of interlacing two sets of yarns at right angles. You can see from this slide there's several different patterns, and even more than this, that can be made from woven yarns. If we talk about weaving the yarns, the lengthwise yarns are called weft, and the crosswise yarns are called warp. Knitted fabrics are going to be put together by using rows of loops, where each row is going to be caught into the previous row. The crosswise and lengthwise yarns also have names, however they're different than the names given for woven fabrics. Crosswise rows of loops are called courses, and lengthwise rows of loops are called wales. The analyst may also encounter felted fabrics. These are more or less matted or interlocking fibers that have been subjected to heat, pressure, or moisture. And they may also encounter bonded fabrics, which are created by pressing fibers into very thin sheets or webs, but then they're actually held together with an adhesive. If a physical match isn't possible, then the fabrics are going to be examined for a lot of the construction type characteristics for that fabric itself. So they'll initially try to determine the construction method, whether the fabric is woven or whether it's knitted, whether it's felted or bonded. They'll also look at the yarns or the threads per inch. If it's a woven fabric, you can count these threads per inch or yarns per inch in each direction of the fabric. They might also look at the yarns themselves to see if they can be described as having a Z or an S twist. They'll also look for the number of plies and the direction of that twist. They'll also count the filaments in each ply and then determine the actual fiber composition. If the fabric itself has color, then they might do analysis or comparisons between the color and the pattern designs. And finally, any other additional items on that fabric would also be examined. So any threads that are holding the fabric together, any buttons or any other decorations would also be compared and examined. If it is a simple fiber examination where it's not a swatch of fabric, the analyst is going to initially try to determine whether or not that sample is natural or if it's manufactured. Then they'll go on to determine the identity of that fiber and also some possible uses for that fiber. If a known sample is available, then they will perform comparative tests between the unknown and the known sample. So if we're trying to determine whether or not a fiber is a natural fiber or a manufactured fiber, just like animal hairs and human hairs, there are very distinct differences in the microscopic characteristics. Many of your natural fibers are going to possess lumens or nodes along the length of the fiber itself. Some of them may also have spiral elements and crystals present. Remember, if we're talking about animal fibers, scales from the cuticle or patterns in the medulla may be obvious. A lot of times a uniform diameter is going to give an indication of a manufactured fiber instead of it being a natural fiber. At times, looking at the cross-sectional shape may give indications whether the fiber is natural or manufactured, and likewise, the fiber being placed in several different solvents and determining solubilities will give an indication about if that fiber is a natural fiber or if it's a manufactured fiber. At that point, the identity of the fiber can then be determined through the use of characterization of various physical and optical properties of that fiber. And then, if necessary, possible uses for that fiber may be given. So if we talk about physical properties of a fiber, obviously that overall color of the fiber itself is a big characteristic. This would be taken into consideration if you're looking at a small section of fabric or also if it is single fibers. The analyst can determine if it's a dye that's present, if it's colored, or is it a pigment that's actually giving that color to the fabric. And then comparisons can be done for dye and pigment composition, because generally the color that you see is made up of several different components, not just one single dye or one single pigment. The length and the diameter of fibers are also going to be examined and noted, whether or not that fiber has any crimp to it along the length of the fiber. Once again, the cross-sectional shape can give a lot of information about the fiber itself and also the solubilities of that fiber. Some fibers will fluoresce. And this is an important characteristic for a lot of fibers. With an alternate light source, the fibers can sometimes be easily identified at a crime scene, but then this same characteristic can also give important information during the fiber exam. So using a fluorescence microscope, you would be able to view the fluorescence of particular single fibers. On a lot of your manufactured fibers, you can determine actual melting points of the fiber. So when that fiber starts to change shape, whether it just softens or if it completely dissolves at various temperatures. An FTIR, one of the instruments that we discussed during the instrumental methods lecture, can also be used in fiber analysis to help identify the generic class of a specific fiber. So it may help identify that that fiber is a nylon fiber versus an acetate fiber. Likewise, a gas chromatograph with a pyrolysis attachment will also allow the analyst to characterize that fiber sample. Remember, the pyrolysis attachment on a gas chromatograph allows the analyst to get a chromatogram about the separation of the components of the actual sample. With the pyrolysis, it allows for it to be a solid sample instead of a liquid or a vapor sample. There are also a lot of optical properties that can be examined for fiber samples. Fibers will also have refractive indices that are very specific to a particular type of fiber. They will also have birefringence values and extinction characteristics. A fiber will also have a sign of elongation, and the fiber may or may not exhibit pleochorism. So all of these characteristics, whether they're optical properties or physical properties, would initially be determined for an unknown fiber. Then, if a known sample is available, the samples are going to be compared on a comparison polarized light microscope. In addition, other instrumentation can also be used in the comparison of the samples. One other thing that can be learned about fibers is the possibility of fabric impressions. A lot of times in traffic accidents, there's going to be extremely hard impact that may occur between an individual and different portions of the vehicle itself. So there may be fabric impressions that are going to be left in that vehicle that might assist an officer in knowing who was in the driver's seat and who was in the passenger seat. In this slide, the top photo is actually a portion of a muffler, and then the bottom half of that photo is a section of knitted fabric. This is actually from an older case at the laboratory where an individual had been run over by a vehicle, and you can see that the knitted fabric weave was actually burned into the muffler itself. The bottom photo is a fabric impression from a traffic accident where the individual that was the driver, his knee actually hit the brake release pedal, leaving a slight impression on that pedal for comparison. Fiber evidence can be recovered, like a lot of our other evidence, from a wide variety of different types of crimes. Usually a very good visual search is going to allow the officer or an analyst to identify foreign fibers at the scene, but a lot of times bright lighting is going to assist, and in some instances also alternate light sources. At times, magnification may also be used to assist in the collection of fibers. The alternate light source can be very useful because you can expose the samples to a variety of wavelengths of light causing some of them to actually fluoresce. Usually it's going to be the dyes or any whiteners or brighteners that have been added to the fibers that are going to cause it to fluoresce. But in some instances, oils and things like that may also cause the fibers to fluoresce. But once again, remember to use an alternate light source. The area does have to be darkened. The newer alternate light sources, the Omnicrom, Lumilite, or the CrimeScope, the three that are shown in this slide, are the ones that are preferred because they are non-destructive to DNA. And you always have to keep in mind you may be examining items that may contain more than one type of evidence. Foreign fiber samples can be collected in several different ways, either by picking, scraping, taping, or vacuuming. You always want to, if possible, remember to collect or request known samples for comparison. Remember, once again, picking your samples with tweezers is going to be the preferred method because this is going to give you the specific location that that item was actually collected from. Scraping can also be very effective for fiber collection, but it can be a little bit time consuming, and once again, like hair samples, it can also damage fibers. Likewise, for taping, it would be very good for a large area, and it does somewhat give you a general location from the collection. It can be time consuming, and then once again, the analyst would have to retrieve the fibers from the adhesive, which may possibly damage the fiber itself. Vacuuming can be very quick and efficient. It's good for extremely large areas, but again, it can at times be too efficient. Your specific location of collection isn't going to be as exact, and it can cause damage to the fiber itself. Once again, keep in mind you should use guidelines for the packaging and storage of fibers. Like hair, a lot of different containers can be used for fiber evidence. You just need to keep in mind that generally these are going to be extremely small samples, so you need to take precautions not to lose that sample once you've collected it. If it is an item that might be slightly wet, that's what you always want to make sure that you place it in something that's going to allow the evidence to dry. And once again, if it is that you're dealing with impacted fibers in a windshield or in a dash, you want to make sure if you're not going to collect those fibers there at the scene, that you adequately protect them so that when they are back at the laboratory, that either you or an analyst is able to retrieve them from the item to do the actual examination and comparison on them. Always make sure that your packages are sealed with tape and the initial is across the seal and obviously adequately labeled. Fiber evidence has been admitted into court for many years. The microscopic examinations and also instrumental examinations have passed Frye and Daubert hearings. When fibers or fabrics are examined for a physical match, usually the examiner is able to say that the fibers were one piece at an earlier time or that they could not be physically associated. Sometimes fibers are just examined to determine the identity of the fiber. So in instances like this, it might not be that there is a known sample for comparison. So a lot of times the examiner might just state that the fibers in a particular exhibit were found to be a certain type of fiber. In some instances, statements may be added suggesting possible sources. And then also, in some instances, the microscopic comparisons may give the examiner the ability to reach one of two results. Either that the fibers were either identical or similar to fibers in a known sample in the color, general fiber type, and microscopic characteristics, or that the fibers were different than a known sample. The reason where the examiner might choose to use either identical or similar might be dependent on how many actual tests they were able to perform or the specific fibers themselves. If we're working with an extremely common fiber, like a white cotton fiber, the analyst may choose to use the word similar instead of identical, even though through the testing they could find no differences. This concludes the discussion on fibers.